All right, guys, here we go with differentials. Example number 3. We're supposed to find the linear approximation to the given function. That again would be some sort of curve, wouldn't it be? Who knows? Crazy old curve, quantity squared. All right, and the point is we're going to come up with, you know what? This is basically asking, find the equation of the tangent line at that specific value of x. I'm so sorry that I can't be as visual as usual. I like to have the graph way over there, and I'm by myself. It's hard to turn the camera, so I apologize for the lack of the visuals. But you guys know that the idea here, we've seen this multiple times. If we want to find a linear approximation, Roman numeral 3, it's the equation of the tangent line. That's it. So this is nothing new. Y equals mx plus b. We're going to write the equation of a tangent line for that curve at that specific value of x. We know the drill. Nothing new. Let's run through it. So we find that ordered pair from the original function, don't we? So again, the idea here would be that we've got the ordered pair 2 comma something, and don't we just put 2 into that function, all right? And look, you put 2 everywhere there's an x. That would be a lot of arithmetic going on. There'd be a lot of number crunching going on there, but that turns out to equal 25, and I did that ahead of time, all right? So you put 2 into the function. So we've talked about that before. You get your ordered pair from that original function. 2 here, 2 here, 2 here, 2 here, crunch, 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 crunch. Order of operations is just arithmetic. All right, the slope, m, we've talked quite a bit about the fact that our slope is going to come from our derivative, isn't it? All right, so again, we use that derivative dy dx to find our slope, or in this case, f prime of x. Now, this would be the chain rule, wouldn't it? Because we have an outside power and an inside quantity. So I believe in this case, that derivative is going to equal 2 quantity in the parentheses. Leave it alone. I made this one pretty complicated. To the first, right? 2, 1. Derivative of what's inside, 20x cubed minus 51x squared. I hope my arithmetic's good on these things. Plus 18x plus 7. And of course the derivative of 11 is 0. And again, that would be the derivative of the inside quantity. Chain rule, right? Chain, chain, chain. All right, and then that would be the derivative, the slope of any tangent line anywhere on that curve. But wouldn't we want to figure out what that would equal for 2? So we put 2 here, 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 here. Crunch, 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 crunch. You know, we've got to get, I warned you this earlier in the semester, that when we get to the mechanical arithmetic stuff, I gotta go. I did this ahead of time. So when you put 2 into that derivative, I hope you come out with -10. So, is that what you got? Yes. Excellent. All right. So -10 would be the slope of this tangent line. And then, you know, we find the other number, the b, back to algebra, right? Y equals mx plus b, solve for b. So I guess I'll carve out a spot here. Y-intercept, B. I feel handcuffed by the board space, guys. I'm really sorry. But anyway, isn't this where we would take that slope of -10 and put it in for m? And then where do we get a pair of numbers for x and y? There's where that ordered pair that we found a while back comes back into the picture. You guys have done this. You've done this 7, 8 times, I bet, already. So y is 25. X is 2, a little bit of arithmetic, 25 equals -20 plus b, add over the 20, b turns out to equal 45, you put a 45 in there, ding, done, right? So that would be the equation of the tangent line for that crazy curve at that particular value of x. We've done that before. So I hope that was not a big deal to you. I hope, right? Okay.